one final example of being able to find the max and the min of a function, and this is a pretty good one on a closed interval, is find the max and min of the function f of x equals xe to the minus 2x. And that's going to be on the interval from 0 to 1. All right. So one of the first things we might want to do is we might want to graph this. All right. And if we graph this on our graphing calculator, it might be tough for us to see what the actual graph looks like and what the key features of the graph are. So here's our calculator. I'm going to go to y equals, and we're going to say x e to the minus 2x. Right? And I'm just going to graph this. All right. Now, what I did was, this is what the graph will look like if you're in standard. I'm going to zoom in. So I hit zoom, and then I just hit 2. And then I just hit enter to zoom in a little bit. And even if I trace it, especially on our interval, it goes up, but it doesn't really help us all that much. All right, so there's not really a clear-cut maximum or minimum. Okay, so unfortunately, the graph doesn't always help us to get us the exact answer. Of course, it can get us in the ballpark because we can just numerically approximate it. All right, so that's why we need calculus. Calculus is going to give us the exact answer. So let's start by finding the derivative. And we're going to use the product rule. So little f is going to be equal to x. Little g is going to be e to the minus 2x. F prime is going to be 1. G prime, using the chain rule, is going to be negative 2e to the minus 2x. Now remember our product rule, f prime g plus fg prime. And so that's going to be 1 times e to the minus 2x plus x times negative 2e to the minus 2x. Okay, or another way to write that is just by doing the multiplication. So f prime of x is going to be e to the minus 2x minus 2x e to the minus 2x. And remember, we're trying to find the critical values, so we do have to set that equal to 0. And then we're going to solve by factoring out the e to the minus 2x. Right? So we're just going to factor out a minus 2x. We factor e to the minus 2x from e to the minus 2x, that's 1. We factor e to the minus 2x from negative 2x, e to the minus 2x, that's just a minus 2x. Now we're going to set both of these equal to 0. And once we do that, then we're going to try to find our critical values. Now, this one does not have a solution. Remember that trick that we did in the previous video, or one of the previous videos, where we try to take the ln of both sides, but ln of 0 does not exist. All right, so this does not produce a viable real solution. Now, this one's really obvious, isn't it? 1/2. So we just add 2x to each side, we divide by 2, and that's in the interval that we want. Okay, so we always need to make sure that whatever our critical value or values are, that they are inside of the given interval. Okay, so that's step 1 for us. That's the hardest part, honestly, is finding the critical values. Now we're going to make a table. Okay, so we're going to have our values of x. Remember, we use the endpoint. Remember, the endpoints are 0 and 1. And then 1/2 is going to be our critical value. And we're not going to plug it into the original or to the derivative. We're going to plug it into the original function. All right, so let's plug it in right here. Okay, x e to the minus 2x. So we are a function x e to the minus 2x. So that's going to give us 0 times e to the minus 2 times 0, which is just 0 anyway. This is going to give us 1/2 e to the minus 2 times 1/2. Or that's just going to be 1/2 e to the minus 1, or 1/2e. And this is where we might want to approximate this. Okay, now this is the exact value. And a lot of times in mathematics, we don't want an approximate value. We want the exact value. All right, but it can't hurt for us to be able to get the approximate value because we have to compare it. So let's go into our calculator. We're just going to do 1 divided by the quantity of 2e to the first power, since e is the same thing as e to the first, and that's going to give us 0.1839. So let's hold on to that. And then finally, let's just substitute 1 back in. And this just winds up being e to the minus 2, or 1 over e squared. And let's plug that in our calculator and see what we get. So we're going to say 1 over e squared, and that gives us 0.1353. All right, now we are looking for the absolute max and min. All right, so clearly the lowest point is at 0, 0. All right, so if we go here, this is going to be our min because it's the lowest point. And then right here at 1/2 1 over 2e, that is the highest value. Right, so that's our max. Right, so here's what we would say for this. Okay, we would say that the absolute min on the interval 0 to 1 is 0 when x equals 0. All right, and we could say y equals 0 if we really wanted to. Right? The absolute max of the function from 0 to 1 is 1 over 2e, and that's when x is equal to 1/2. All right, so this is something that we can't get out of our calculator. All right, our calculator can approximate 0.1839, but it can't give us the exact value. That's what calculus does for us. It gives us precise values. So those are the things that we really want to hold on to, especially to get out of this class. Right. So in the next section, we're going to start taking a look at 2 important theorems. One's Rolle's theorem, and then the next one is going to be the mean value theorem. Well, before you move on to that, it might be beneficial to ensure that you're okay being able to find the critical values and the max and the min of a function on a closed interval, so that way you can proceed on to the next part with a little bit more ease.